elimination. By this time, we're going to solve for b, and we should also be having 0 as our b. So let me have these two equations again, 14 2a plus b. Now by this time, we are going to eliminate a because it is b that we are going to look for. So to eliminate a, since this is 2a, this has to be negative 2a. That's why I multiply this by negative 2. As a result, we will have negative 14, negative times a, that's negative 2a. Anyway, your multiplier here should be multiplied to all the terms inside the parentheses. So negative 2 times b, that will give us negative 2b. Then rewrite the equation below, 2a plus b. So it is so obvious that your a will be eliminated. So negative 14 plus 14, that's 0. Negative 2a plus 2a, of course, eliminated. Negative 2b plus b, that will give us negative b. And again, divide by negative 1. So this will give us b is equal to 0. There you go. Which is the same as the value of b using the substitution. Okay, so let us have the last look for the by substitution. So this is the method of substitution. Anyway, you can watch again the video. Anyway, you have your freedom to do it. So there you go. That's by substitution. A is equal to 7, b is equal to 0. And by elimination, so you have there, eliminating b to solve for a, and this one here is eliminating a to solve for b. And obviously, we are getting the same answers as this one, which is by substitution. I hope you're getting it. Now, we already have the values for a and b. Let us now proceed to this one. There you go. So this is the model for this, and we already have found the a, which is 7, and b, which is 0. Finally, we now have this model for this problem, the jeepney ride. Okay, with this model, we can further simplify this by having it as a of p is equal to 7p. And going back to this table, we're looking for the fare if there are 17 people. That's why if your p now is 17, then a, your p is 17, is equal to 7 times 17, and that will give us, what is 7 times 17? 190, right? So the point is, if you already have the model for a particular real-life problem, it would be easier for you to solve the missing item given or using the model. Okay, so that is for the linear function. Okay, so let us now proceed to the next one. Okay, now let's say you have a store, okay, and then you are fixing your canned goods, and then most of the stores, let's say not most, or maybe let's say it's a must for you to arrange these canned goods into layers, forming a pyramid, or yeah, forming a pyramid. No? Let's say for the if you have um, for this figure one, okay, so that's for the figure one. You have one can, and then for the figure two, there, that's your figure two, and for the figure three, there you go, there, that's your figure three. Okay, if you will continue this, then let's see if there is a pattern or a model for this problem. Now, uh, let us have notations for this. Okay, so let f be the figure number, and then let's say these are cans. Okay, so C of f will be the number of cans. So let us now construct a table of values. So for f, figure can C of f. So for figure 1, of course, if you have a zero figure, of course, there will be no can. For the first figure, you have 1 can. For the second figure, you have 3 cans. For the third figure, you have 6 cans. Okay? And then if you will continue that, how about if I will be asking you, on the 10th figure, how many cans will there be? Again, you can answer this by doing it manually or by having some drawings, so you could answer me. But if I'll be asking you, how about on the figure 85th? Of course, you can dare me to do that, but the time does not permit all the time. Okay, so that's why we have to make a model. We have to make a model for this one. Now again, just like what we had in the linear function, we have to do some inspections first. And just like what we have here, the first differences of the independent variables should be the same before we can proceed for this one, because this could be a linear function, or if not, a quadratic function, or if not, neither of the two. Let's see. So 3 minus 2, that will give us 1. 2 minus 1, that will give us 1. 1 minus 0, that will give us 1. See? So the differences for the independent variable are all the same. So let's proceed now to the dependent variable. 6 minus 3 is 3. 3 minus 1 is 2. 1 minus 0 is 1. Oops! The first differences are different. So let's continue. Maybe they have the same second differences. 3 minus 2 is 1. 2 minus 1 is 1. There. So, if the second differences are the same, for the dependent variable, then if the second differences are similar or the same, in the similar for the dependent variable, then this table of values is referring to a quadratic function. Did you get that? So again, if the first differences, let us try to look back. If the first differences of the dependent variable are similar, then it is a linear function. But if the second differences are similar, then it will be a quadratic function. Let me encircle that. Okay? So, for a quadratic function, we must follow this one. Okay? Again, for a quadratic function, we will be having this pattern here, this model, this function, this equation. Again, whatever term you want to name it, that's fine. So let me write that here. So you have here the y is equal to a x squared plus bx plus c, since it is quadratic function. And our y here is your c of f equals a, our x here is the f, so af squared plus bf plus c. Anyway, it's up to you if you want to use the notations that we use here, or you may stick with the y and x, as long as you know what would be your y and what would be your x. That's fine. Okay? Okay. Now, for this case, if it is a quadratic function, we will be needing 3 sets of points. For the linear function, since we only need to look for a and b, 2 variables, so you only need 2 sets of points from the table of values. But in this case, we have a, b, and c. So 3 variables, so 3 sets of points. 2 variables, 2 sets of points. I hope that is very, very clear. Now let me use the 0, 0. Why? Actually, I could have removed this and I should have started with the 1, 1. Now my point is, of course, I want to strategize, and 0, 0 could help me with that. Okay? Anyway, you will be realizing later as we go along with our solutions. So let me have 0, 0. So the 0 here would be our f, and then the next 0 would be our c of f. Therefore, this will give us 0 is equal to a times 0 squared plus b times 0 plus c. So to simplify, of course, that's 0, 0. Therefore, we already have c is equal to 0. So I hope you are getting already my point, why I considered 0, 0 first before any other set of points. Because from that, you already have a value for c. Our problem now is finding the a and b. Okay? So, using 1, 1, f, c of f, then this will give us 1 is equal to, let's go back here so we could have a guide. So the c of f is 1, a, still a, your f is 1, square, plus b, your f is 1, plus c, which is already 0, so you can already use that by substitution, so 0. And this will give us 1 is equal to a plus b. Okay? Similar to, almost similar to what we got from the linear function. Now, let me have 2, 3. 2, 3. So my 2 here is the f, 3 there is my C of f. Then it will give us 3 is equal to A. Your f is 2 squared B. F is 2 plus, again, C is 0. Then 3 is equal to 2 squared is 4 times A, that's 4A. Then plus 2B. There you go. So again, you already have the C. This is our model anyway. This is our guide. We already have the C, which is 0. We do not have yet the A and the B. And these are the two equations that we will be needing to solve for A and the B. So let me do again the two methods. The first one is by substitution. The second one is by elimination. Okay? So by substitution. Okay, don't worry. Just like what I have promised to you, I will give you shortcuts for this one. But you have to be patiently waiting for those shortcuts, okay? Because it is more important for me to go through these processes so that once you already do the shortcuts, then I am already confident that you know already what's going on. Anyway, for your activities, I will be stating there in some of the problems whether you are going to use the substitution, elimination, or you do the shortcut. But of course, for the exam, you may do the shortcuts because you only have, well, like 1.5 hours to finish the exam. Well, okay. So I know you're already interested in the shortcuts, but let me finish these ones first. Now, for the by substitution, just like what we had for the linear function. So from this one, I can have my A to be 1 minus B. Anyway, I am always getting the A instead of the B. You can also do that. Like, you may have B, which is equal to 1 minus A. You could also have this one. But since I have already have the A is equal to A minus B, then let me continue this one. So from there, A here is the same as the A here, B is the same as the B here. So therefore, we can now apply the substitution. So from here, so you have 3 is equal to 4. Instead of writing the A, right now the 1 minus B. Then plus 2B. Okay, so continue. 3 is equal to 4 times 1 is 4. 4 times negative B is negative 4B. 10 plus 2B. Okay. So transpose the 4 there. Then that will give us 3 minus 4. And that is negative 1 equals negative 4B plus 2B. That will give us negative 2B. To solve for B, divide both sides by negative 2. Negative 2. Therefore, we now have B is equal to negative divided by negative is positive. So B is equal to 1/2. There. We already have the B. We already have the C. Now it's time for us to find the A. And from here, again, A is equal to 1 minus your B is 1/2. And that will give us A is equal to 1 minus 1/2 is 1/2. So that is by substitution. So we have the A as 1/2, B as 1/2, C is equal to 0. Now let's do the elimination if we will still be getting the same values for these three variables. Okay, so if we will apply elimination, your A should be 1/2 also, B should be 1/2 also, C should be equal to 0. Okay, let me put this aside. And let me go back to the table of values. There you go. Anyway, again, this problem is about, where is it? This one. Okay. There. Now let us have by elimination.